That's really about as good as one could expect or hope to receive from a sub-billion parameter model. We are a tech and tasty lane in Silicon Valley. For today's video, we're going to be running some local AI on the brand newly released MacBook Neo from Apple. Now, fun fact, a lot of folks have said this is MacBook Neo. It is actually pronounced Neo, kind of like meow. And I just completely made that up. It's called the MacBook Neo. I don't know, it is pretty late, but what we see right here, this is running, and it's probably hard to see because of the glare. This thing is currently running Llama 3 8B in LM Studio at a 4-bit quantization using the MLX community quant at a relatively reasonable speed. So for today's video, we're going to be playing with a few different sized LLMs on this machine to see how it does in terms of its speed. And then beyond that, we're going to see how well Claude Code can actually work to optimize this system and try to continuously benchmark the same model to see if any of the things Claude can figure out how to do just by researching online, being that this is a brand new release and architecture for an Apple laptop, to see if it makes it speed up or slow down. So really, that is going to be our video today, and we can see this did just finish a simple story generation using Llama 3 8B at a respectable token speed of 11.6 tokens per second. And I should also just throw this out there. This isn't sponsored or anything. Apple didn't send me this. I just went and purchased it because I think it's really cool, and there's about a 40 to 60% chance that I do end up cannibalizing this for some form of retro aesthetic cyberpunk 3D printed laptop project. The MacBook Neo is sitting here on the table in front of us with LM Studio installed, and although this computer is in no way designed to be able to run local AI models, the rapid increase in popularity of them, I think, coupled with the fact that I want to see what this thing can do with some tiny models, has made me very curious to at least benchmark it to get some real-world speeds on a few choice tiny models. So right now we're loading in Qwen 3.5 4B, so a 4 billion parameter variant of Qwen 3.5. This is a 4-bit quantization using the MLX community quant through LM Studio. I'm trying to load this in right now with a context length of 16,384, and assuming we do get it to load in, which we can keep tabs on the current process, just seeing this blue bar move towards the right of the screen, I'm going to give it a simple coding task because that will give us a good measure of the real world speed, with the plus side that we actually get something to take a peek at visually following the generation. And then of course, once this is done, we'll load in a few other models that are around the same size just to get a feel for how they run in terms of speed as well. Now this model we can see right there, the prompt processing occurred quickly as one would expect, being that this prompt is extremely short, and this is a thinking capable model, so the thinking by default right here is enabled. Therefore we see its chain of thought is just giving itself an outline of how it will go about creating this website result, which is in and of itself kind of what it says here, an unusual combination: Steve's PC repair and seafood restaurant. So I'm going to allow this to just generate, and we see this chain of thought has already finished, and it is now going to begin spinning out the code, and we'll see if this is a passable speed for using, keeping in mind that these models are not necessarily going to be knocking out extremely high-end code results, but even having a laptop like this that does give someone the opportunity to play with local AI at an affordable price point. I mean, face it, no one's buying this, well, aside from perhaps folks like myself, no one's buying this to run local AI, but if someone happens to buy this and find themselves interested, hey, I wouldn't mind trying a local model, it's interesting to see what it can actually pull off. So at the conclusion of our first test here with Qwen 3.5 4B at a 4-bit quant, this produced 4,052 tokens at a total speed of 17.64 tokens per second. Now, of course, it also did produce a website for Steve's PC repair and seafood restaurant, so let's take a peek and see how that actually looks. And here is our MacBook Neo local AI website generation result, which is a interesting sentence to say. Okay, I'm going to be honest with you, this really this is not that bad. We have a toggle slider, so we can select seafood or PC repair. Very, very elegant. So it kind of dims the one that is not currently selected. I have to say, for a tiny little model like this, I think prompt adherence was actually quite good in that it took this really abstract concept of something you would not normally see together, and it made it so the user could focus specifically on one at a time without the concept of this overwhelming them. I'm impressed with this. Do these change with the slider? No, so it seems like the hover thing is only really just for the slider, but regardless, fix your broken reality. We have hardware repair. We do have hover effects on these results as well, which, to be honest with you, a year or two ago, to see this result from a 4-bit quant of a 4 billion parameter model would be very, very impressive. You can either book PC repair or order food. We are a tech and tasty lane in Silicon Valley. Next up, we're loading in the LiquidAI LFM1.2 1.2 billion parameter model. This is in an 8-bit quantization, and I've just loaded this in with a 16,384 context length. Our next step is just to paste in the same exact prompt, keeping in mind that this is very likely not going to produce a result that is as aesthetically pleasing as the Qwen model, but this should be quite a bit faster, and these liquid models, as we see, are known for, one, their speed, but their intelligence, especially when considering the relatively small size of them. So this model is quite a fantastic match for this specific computer. And this result was a total of 1,651 tokens at a significantly faster 35.46 tokens per second. Of course, a very lightweight model, but an 8-bit quantization of one nonetheless. And we also did get a website generation result, which we can now take a peek at. So here's our LFM 2.5 1.2b model result. And again, really not a horrible result, especially for the size of that model and the speed for which we got it on this little tiny MacBook Neo. It is a bit simpler, but we do have a very simple contact form. We have some hover effects, and it did correctly name this, as well as understand that the hover effect cards should contain things both related to PC repair as well as seafood. Still, as someone has always mentioned that I should try to resize these results as well, I know this is probably not necessarily like the best specific test for that, but nonetheless, I would like to just quickly try that as well to see if these do scale to mobile. This one scales very nicely to mobile. Next up, and this is something that is very likely not going to work, I'm trying to load Qwen 3.5 9B at a 4-bit quantization in. I have turned all of the model loading guardrails off, which if they were enabled, it would automatically prevent me from even trying to load this model in. Considering that even though this has 8 gigs of RAM, there is some allocated for the system, it did load. I had to... So I've tried loading this before, but it was at the default context length that it will load in at, which is 4,096. I dropped that to 512, and it's actually loaded in. So our context length here is going to be abysmal and very likely immediately taken up by the chain of thought, or it will just go haywire and not even properly respond to our results. But I'm going to ask it a very, very simple math question. We won't send the website prompt because that will trip it up. And we'll see. So if this can actually handle running the 9 billion parameter model, that would be kind of cool. Okay, so unfortunately, we just exit code null, so it crashed. And so as we saw, sadly, there our 9 billion parameter model did not work. We were able to get it to load in with a context length of 512, but nothing happened. Now, kind of on the opposite end of the spectrum here, we're loading in Qwen 3.5 0.8b at an 8-bit quantization. I have loaded it in with a context length of 16,384, and we'll paste our website prompt just to see what this thing can actually bang out in terms of a decent looking website. And let's see how the speed is here. I'm going to guess off the bat, based off what we saw with the LFM 1.2b, I'm going to guess 46 tokens per second. All right, we're about to see the final speed result here. I think I guessed 47 tokens per second. 45.78, I'll take it. And of course, let's take a peek at the result. And that total generation was 4,543 tokens. And let's see our 0.8 billion parameter Qwen 3 model. That's really about as good as one could expect or hope to receive from a sub-billion parameter model, especially considering that it was just an 8-bit quant, which is all right. This did surprisingly well. Fix your PC, enjoy the sea, and it did understand, of course, the top mint. I would almost go out on a limb here and say that was a better result than we got from the 4 billion parameter model, which is somewhat curious. It's a really well done website. It even has hover effects, the emojis or whichever icons it chose to represent each of these individual cards are actually spot on. This is a very, very impressive result. A MacBook Pro M2 or M3 for only $1,200. Kind of a ripoff. Fresh catch though for 15, not bad. Maybe they even out. And a good looking contact form, even a relatively clean footer. That's pretty good. All right, so I've set the context length to 2048. Let's see if our Llama 3 8B at a 4-bit quantization will load in and then allow us to actually speak with it. All right, so it is loaded. I'm just going to send it a simple hi because this is not a thinking model. It will just immediately respond if it is going to work. If not, we'll just get one of those error messages that pops up in the bottom right. Yes, it does work. Not bad. So Llama 3 8B at a 2048 context length running at 11.3 tokens per second at a 4-bit quant. That's really actually not bad. This is a little better than I had expected. We'll try it with a longer prompt. Small village in Tuscany. She lived with her grandmother, Nona Rosa. Okay, well, the context seems correct. Now, of course, the goal here is not to check its storytelling ability. It's just to see how the speed is over a longer generated result, aside from just a response to us saying hello to it. So across that 695 token generated story, it was 10.6 tokens per second. For a 4-bit quant of Llama 3 8B, that's really not bad at all. Now, something else I'm curious about is just heat, and I'm putting my hand on this system. It is metal, so by nature it will be cold unless the room is oddly hot or the system itself is oddly hot. Really, as I run my hand around the edges of the top case, the only portions that I feel at all any heat are really from the escape key in the top left, probably over to around F6, and then everywhere else is pretty much just cold. So that's cool to see as well. There are no fans in this system or anything like that. So in terms of cooling, it is entirely passive. I've decided to enlist the help of Claude Code here, and we're going to test Claude Code's ability to basically give this system the best chance to run models at a decent speed. Being that this is such a new computer, the Claude Opus 4.6 model is not going to have any knowledge of the existence of this machine in its training data, so it's going to have to rely on searching and finding information about this system to at least try to give us some insights or set the system up to run AI, perhaps not using LM Studio, but something a little lightweight. And I've just given Claude the task of researching the new MacBook Neo with its Apple A18 chip, come up with a plan to install dependencies and basically set up the environment here so we can play with local AI, and then finally find ways to optimize this on this specific machine to try to get the best possible speed. I don't have any information about a MacBook Neo. What I can do, if you tell me what chips you actually have, bro, look it up. Now we see, even though its initial insistence that this wasn't necessarily a verifiably existing product is going to web search, and now it's coming back with results, and it will culminate in information about this system and its architecture, and then lead us into potential ways to get things set up here. Good call, it's real. Let me also look up the best LLM setup for this hardware, which it's very likely not going to find anything about. And Claude has now given us the full breakdown for our MacBook Neo, beginning with the recap of specifications. Our memory bandwidth, it reports here as around 60 gigabytes per second, which is pretty low, very low, in fact. But this is an iPhone chip and a laptop. 8 gigs of RAM and lower memory bandwidth than the M series are real bottlenecks for local LLM. It's giving us now a step to install these specific dependencies. It has opted to suggest Llama for ease of use, very likely. Alternatively, we could also use MLX, which is Apple's own ML framework optimized for Apple Silicon, and it does give us the command to do that as well. Now, what's cool here is it's giving us some specific suggested models as well as their sizes and expected tokens per second speed that we may receive, which I find pretty cool. And this actually included an 8 billion parameter Llama 3, which I wouldn't have expected it to. 10 to 18 tokens per second pushes the limit, and as we just saw with Llama 3, it was getting like 10 to 11 tokens per second. It's also mentioning that because this system is only passively cooled, you kind of need to be careful because if it gets too hot, it will throttle and the performance will drop even more than it would be at baseline. It's giving us some optimization tweaks for memory management as well, which is very important, such as just lowering the context length, which you can see we did for running the Llama 3 8B model, and it's telling us to use quantization. So I'm telling it to specifically focus on getting Llama 3 8B running on this system in the most optimized framework to do so, so it's going to have to opt to use Apple's MLX. Additionally, I want to see if it will actually go ahead and try to turn off any system or background services to lower the memory footprint to allow us to benchmark this model at a high rate of speed. And it's checking our current memory And this is something that I don't necessarily all the time see these agentic coding tools used for, which is not even coding, just to actually set up system dependencies, find ways to optimize the system. I find it is incredibly useful to be able to use things like Codex or Claude Code to do stuff like this, where, okay, it's going to run all of these bash commands right here to kill a bunch of background services running on this system that are going to inherently be taking up some memory footprint that could instead be used for our local AI experiments instead. So this is why these agentic tools are more than just coding capable. They're actually capable of handling system dependencies and setup and things of that sort, which make them very, very cool. And it's now set up everything aside from what we're going to see right here, which will initiate the download of the specific model that it's going to benchmark here. But it's going ahead and basically autonomously running the benchmark now to allow us to generate the story time at the 4-bit quantization MLX Llama 8B model in 2048 context length. And now we're seeing right here, although it's a bit difficult comparatively to how it would look in LM Studio, we see a story generated here, and we're waiting for the story to finish the generation. This is running this in the the MLX community Llama 3.18b instruct 4-bit quantization, and we've just had it run the test with generate a story or something of the sort. Same max context length that we ran in LM Studio, just with having Claude basically run this all in a way where we told it to optimize performance and try to shut down any background things that will get in our way or give overhead that we don't necessarily need. All right, so we have given a specific analysis, and we also get a nice little framework here, or a nice table of our benchmark result. So the framework was Apple Native MLX. The specific model was Llama 3.18b at a 4-bit quant. The context was set to 2048. Prompt processing was 33.7 tokens per second. Generation speed was 11.2 tokens per second. And peak memory was 4.735 gigabytes out of 8 gigs. So the peak memory is not really that bad at all. And now I'm telling it to try to further optimize things, but without messing with just like, oh, okay, I'll drop the context length to 512. I wanted to try to do it either using flags with MLX or turning off more background tasks. I just want to see like what we can push the ceiling to in terms of allocating RAM to the AI versus just leaving it for the operating system overhead. And it's complemented itself in terms of what it found, such as several levers: KV cache quantization, GPU memory allocation, memory compression disable, process priority greedy decoding, and more aggressive process killing. Let me apply everything. Please do. And we can see there something happened where the system kind of blacked out and came back. And partially what I want to showcase here again is just how some of these agentic coding tools can go ahead and do system stuff aside. I'm not just using this to vibe code like a SaaS web app. Yeah, I'm using it to handle my system, basically, and dependencies, and I like that. And now it's going to run the benchmark once more with all the optimizations that it's done now. This is very interesting. It's now trying to run a command that will utilize speculative decoding, which is going to use the tiny 1 billion parameter model there to try to predict the tokens that may come next during a forward pass, and the larger model can just verify if those are true or not, instead of having to generate them by itself, which will speed things up. That's a non-scientific way to explain it, but there's a very good Google article or demonstration on speculative decoding for anyone interested. You can just Google search speculative decoding Google, and it will come up with the article, which has some cool visual feedback and how it works and things of the sort as well. So I'm going to find this interesting to see what it does. It's saying, look at that prompt processing jump. Let me also try speculative decoding, which is what we're seeing now. I did not actually see the specific readouts from our second benchmark test, so I'm going to just wait for it to finish trying the speculative decoding task as well, and then I'll see what it reports for runs 2 and 3. So here we have the culmination of our results from runs 2 and 3, which were just Claude trying more optimizations that it found. Our baseline with running the generate me a story at a context length of 2048 with the Llama 3.8b model in a 4-bit quantization was 33.7 tokens per second for prompt processing speed. The optimized speed was 71. We can see right there, that's a change of 110%. Following that, we have our baseline for the token speed, which interestingly was the absolute same across both runs. So both the optimized and the baseline run had the exact same token speed in terms of the generation, which is like how fast the words are appearing on the screen when it is telling us the story. Peak memory stayed identical. So the optimizations that it did for the second run here was pretty impressive in terms of the increase in prompt processing speed. If we scroll down now, we can see that with the draft model, things became much worse, but that is attributed to the fact that the peak memory jumped from 4.735 gigabytes when running just the Llama 3 8B model to 5.421 when using the draft model for speculative decoding, which is that 700 megabyte overhead. Worse memory pressure, slower than optimized, and it's just now listing what worked. So quantizing the KV cache reduced bandwidth pressure on the KV cache reads. Greedy decoding, a temperature of 0, eliminates sampling computation. So instead of trying to figure out like which, it calculates a distribution of the tokens and it will pick like the top X. A temperature of 0 only picks the one that's specifically like the closest to. That's non-scientific, but I didn't do this. Save this as a script I can run before benchmarks. Okay, well, I was trying to. And the final thing Claude gave us was a specific script to run the benchmark that will kill these processes, ask for our password, because it's also going to allocate more memory to be allowed to be used for MLX, and disable spotlight search indexing, which basically is just making it so when you search with that little button right there, or you press like command space, you can search for an application and it quickly shows you files. We have disabled that. So now we're running our specific benchmark script thanks to Claude that saved it also with like the way that it found to optimize this to make it faster. It's using greedy decoding. It is using a quantized KV cache. So whatever our result is here, if it's 11.2 tokens per second, which is what we were getting when we had Claude run these specific results, it's just basically saying you're hitting a wall because the memory bandwidth is 60 gigabytes per second. You would need a faster memory bandwidth. But I do find some level of interest in just trying to play with the system and tweak it, and that was only 11.08 tokens per second. So we were receiving 11.2 earlier. This was arguably a bit slower. But there's so many hobbyist ways to just play with stuff like this. Really, the culmination of this video was I wanted to test some stuff with this MacBook Neo, just in terms of stuff that I like to do on this channel, and I know other folks are going to be interested in, to get a feel for its speed and its ability and what some of the models it can run are and at what speed. Additionally, I almost do have to wonder, like, if I rip this thing open and put like a real fat heatsink on the chip, like there should be a MacBook Neo speed competition, whoever can engineer it like to not throttle. I don't know. I'm just talking off the cuff here. So really, that's going to conclude today's video of looking at the MacBook Neo and seeing how well it can handle local AI. Overall, the system, I very much like it. For someone who is interested in purchasing this computer, they're probably not going to be interested in local AI, but the whole thing I wanted to explore is if that does change and someone finds that they have this specific system on hand, can they actually do some playing with local AI? And I would say absolutely. And that's pretty cool for a computer at this price point in the Apple ecosystem. So with that, that is going to wrap up our first look and testing of local AI on the MacBook Neo. If you have any questions, feel free to leave them in the comments, and thanks for watching.